learning comes, and the deep learning also comes as a part of it. And then we have data science, which kind of overlaps with the maths and statistics, right? Whatever is there, right? So basically, you kind of try to merge math and stats along with the AI, and that becomes data science. So that is the common thing between these two things, right? And then we saw that this is how the overall stack is going to look like. That at the bottom of it, you have your CPU, GPU, TPUs, whatever are there. And then we have cloud providers on top of, which is providing the hardware for you: AWS, Azure, um, Google Cloud, and of course on-prem as well. And on the right hand side, you can also see that what are the different personas of the users who are going to work in the given layer, right? So we have a hardware layer, infra layer, platform layer, ML lifecycle, and workloads. So these are different layers are there. And then once we have the basic infra like our compute and memory, then we kind of deploy a layer on top of it, which would give us a way to kind of program our infra and then get it on demand. And for that purpose, we have this platform layer, and Kubernetes fits there very nicely because we know right now how we can kind of scale our workload on Kubernetes, how we can add more nodes in Kubernetes, and so on. And then we have some very specific AI/ML stuff or kind of layers on top of it, like K-serve, right? So what is K-serve? With the help of K-serve, we can serve different models, which we'll kind of try to kind of delve into in some time. So now, though this layer is there, Kubernetes can do the orchestration of the regular workloads very well, but there are some limitations or there are some shortcomings in the way we can deploy the AI/ML workloads on Kubernetes. And that is what this particular paper wants to kind of cover, that what is that missing piece, right? Or what is there right now, what is the missing piece which we don't have in the cloud native ecosystem, and how as a cloud native community can come together and solve those problems for the AI/ML workloads, right?
I,
Yeah.
do you know is there an alternative to Kubernetes? When you are dealing with AI.
In a way to scale the workloads or run the
Yeah,
workloads, is it?
yeah. Means
Yeah,
platform. Like take out Kubernetes. What is
yeah.
the other
So
alternative?
correct. So see, as per my understanding, what you require there is a way to serve your models. Correct. So now, what is the model? So let's just try to kind of understand that term also a bit more. So what happens is data science team, right? Whatever you see at the top layer, right? Data science team, right? What this team does is they look at the data which is there right now, whatever the access data they have. For example, think about, I'll kind of go back to my like performance data only, right? For example, think about you have looked at the performance data of 10,000 machines, for example, which runs Linux, for example, right? That data you have somewhere with you, correct? And now what data science team would do is they would kind of try to build, or they will try to find out something from that particular data. So for example, if I know that if somebody is running database server, and if my memory is 80% filled, I'm definitely going to see some performance degradation, for example, right? Other example can be, for example, let's say you are having your system is becoming too slow, for example, right? And when, let's say, if I'm a support engineer and I would have identified the problem that your system is running slow because of so and so reasons. For example, one example can be you have less number of CPU and you have more number of programs which wants to use a CPU. So that's a load average kind of a thing, right? That your load average is high. So if as a support engineer, I have solved those problems. So think about, there is a database of the system logs what I have, and there are support people who have solved those problems. Correct. Now, data science team would come together. They will look at the data. they look at the support tickets and they'll create some kind of a model saying that if somebody has complained about performance data and performance issue on the system, and if I see the high load average kind of a thing, right, then I can understand, okay, or I can deduce from there that they may be running low on the CPU. They should increase the number of CPUs what they have on system, for example, correct? Now that knowledge would become the model for me, correct? So that the data science team would kind of make it happen. So they'll kind of look at this data, whatever, and they'll build a model. Now that becomes a model that is like, you have seen some previous data and you have some domain knowledge and you kind of combine together.
Which stateful sets. Then that's where we introduce stateful sets, and people are like SaaS and ISVs are running databases on top of Kubernetes. It's not suggested for end users, but like if somebody's running a SaaS service or a database as a service, they can do it with operators. I need to have the knowledge.
Yeah,
Um, it's the same thing right now with, let's say, 2 years from now, we're going to say, remember when uh, we only run web applications and databases, and we didn't run anything about machine learning models, right? Either training or serving them. So I think we're at that point where like a lot of companies and a lot of open source projects are trying to figure out how do we enhance Kubernetes a third time, right? To make it be able to do machine learning. And there's I posted a link in the chat that in KubeCon there was a discussion to create a new working group in Kubernetes upstream to look into these accelerated workloads, like in general, like serving or training. I think they're looking more on serving. And I foresee that we'll have the same thing of like coming up in a year or two of like the CRs, right? Custom resources or resources in Kubernetes, that this is the way to schedule or resume. Uh, yeah, some of the challenges. There's a lot of challenges like getting the data, downloading the data. You have a training process where it takes hours and then something fails. How do you restart from the beginning? How do you restart where you're like restart the training where you at, right?
right.
Saving that state. That's a challenge. So I think for the majority of folks to get started, it's like there's two areas, like the training and the serving.
Yeah.
So those are the challenges that I see.
Yes, I thought recording was on, but somehow recording was not started earlier. So it's funny. I think I clicked it, but anyway, yes, those are the challenge. What is there? Like, of course, that right. Like, if you look at different layers here, right, of the entire AIML thing, what they are doing it right, and of course, as all of are in this new in this field, right, we can't foresee all of that, but of course, as part of this paper, right, they have put down together, right, that the entire pipeline, right, consists of different things, right? Data preparation, collection, cleaning, feature engineering, training, then serving, storage, model registry, model serving, observability. So if you look at currently what Kubernetes has, right, um, and what challenges it can face down the line, right? Like I think some of them already highlighted by Carlos, right? The storage part, right? How much storage you would be needing to prepare the model, right? And then the model need to be distributed and scalable, correct? So you don't train the model with a small data set, right? If you train with a small data set, the output would come from that model is very, very weak or very less useful there, right? So you train the data from for more and more input there. That's what we are saying, that why there are models coming of different sizes, right? So if you look at model of 3 billion parameters, 13 billion, and maybe whatever the billion parameters, they are going to come later as well, right? Now, all of these parameters are nothing but how many data points you have in general, right? And for that, you require humongous amount of storage to kind of, first of all, store the data and then perform the computation of that, right? And it's not that the computation happens only once. You have to do a multiple iteration of the computation to get the right model for you to serve your customers and serve your end users who are there, right? Now to run the scalable or model preparation part, right? It requires to kind of have multiple compute work together in a way that they can do this matrix multiplication, all those stuff in a way. So all of those challenges need to be solved if I deploy on Kubernetes. The same thing, right? For example, if a node dies, right? If a node is serving or is building a model, and if the model dies, what will happen? Correct? It's going to be a challenge, right? So other thing can you can think of, like for example, I have to build an entire workflow. How would I build an entire workflow with the existing Kubernetes ecosystem? What we have, or we have to kind of add something more on top of it. Observability is the biggest challenge I believe what people are going to face, right? So let's say you are evaluating 10 different models to kind of get the right performance or right to serve the models for your end customer in the right way. So think about you choose the model from, let's say, some open source model or maybe a proprietary model, whatever it is, right? You have a use case, or let's say think about you want to uh, look at the financial data of a company over the years and predict how it is going to perform in the next 2 years, for example, right? Now there are going to be some models which would have trained a lot with the help of, or they would have trained a lot of performance data of not sorry, financial data. Correct? I'm saying that you're taking a company's last 10 years financials and predicting whether this company would do better in the next 2 years or not. Right? So if there's a model which would have had lot of trained data with financial data, it can do better. Right? And you have to compare 10 different or 5 different models for that, right? So when I serve those 5 different models, I have to get the performance of it, right? Like which model performed better, right? Which model can give us the data in the least amount of time, right? Few millisecond of latency, correct? Or even the output what has come from the data, the output what has come from that particular model is useful or not. So I have to do all of this thing, right? And I have to see that okay, at a given layer, how much time it has taken to um, serve my request. So that is another challenge. What I see that is going to be there, which we have to solve, right, as the ecosystem of cloud native, right? Because we may not have right tooling around right now, which can tell us, okay, this model performed better for this workload, kind of a thing, right? So those things to take care. Let's look at what is covered in the paper here. Preparation of the data itself, right? Security, right? Security is more critical given since observability also there, right? So, yeah, okay. Data preparation. So yeah, so managing large data size, ensure that data synchronization during development deployment, right? So basically, we have to kind of make sure that we can handle that in a optimal way. Data size, as we are saying that, right? AIML models is increasing faster than most law, which means, of course, the amount of data requirement, synchronization of that is going to be huge, right? And what you mentioned here is, um, uh, and currently, as ML workloads don't have any industry standard interface. Um, okay, so what happens is this point, what I got from this particular chapter there, right? What they are saying is data scientists who develop these models, they run it with a local available data set, what can fit in their machine, right? And then when they go in production, they have a kind of different way of serving them or doing the stuff what they were doing locally, because the amount of data available for the real workload is huge than what they can do on their local. And that is maybe because what they mentioned here is there is no industry standard interface, and um, there will be different way of doing the same things in this kind of AI ML workload, way, whatever the existing way doing of things right now. But we need a way by which we can put a standard towards it, and through which we can do better. Right. Um, yeah. So, for example, what they're talking about here is right. If we have put down those things, let me just see. For example, users can leverage API of native. Yeah. So what they're saying is rather than kind of doing working two different kind of scripts, right? Like uh, ML engineer working with the local Python script locally, but when they go for the production, they use a different kind of scripts which can distribute the execution there, right? But if we use Kubernetes native ecosystem locally, then whatever is running locally, it can be done on the remotely as well, or wherever we are deploying those models. Correct. That is there. Uh, Data volumes, of course, it's a, cross-cutting issue, which of course can require an approach with respect to, of course, AIML team, the way they are working, as well as from the Kubernetes ecosystem. Also, we have to handle such large data set, data volume there. Then your data governance issue, basically how we would basically make sure privacy, security, and ownership, right? All those things are handled, right? So, for example, if I use someone's data and build a model, and then how I'm going to kind of um, make sure that how I put ownership on top of it, and who owns it, how do I give the whatever the royalty to the owner, and all of those things need to be handled in the data space here. uh, right. Then mitigating biases, and of course we need to make sure that the data what we are using to build the models, it is not biased. Let's say if you build a model by taking only given geography, so for example, if you build your model based on the only the Asia continent there, right? And if you run the model for a different geo, right, it may not work out. So those things are need to be handled as well. Um, yeah. For model training, so model training is not a single step process. It's a multi-step process. And now, if there are multi steps are involved in this, coordination of them can become very challenging. Correct. And then we need to make sure that the cloud native ecosystem can understand that particular problem, that I am running the training in different steps, and if something goes wrong, I should be able to kind of start from wherever I left off. I think already covered earlier. Um, then we have rising processing demands. So of course, right, as we kind of try to crunch more and more data, we require more resources for that. And of course, we all know the GPUs are not available, first of all, at the quantity, as well as they're very expensive right now. And even if it is, I mean, if it is available for us, we need to make sure that we rightly use them, right? And that is what this particular different modes of the GPUs we talked about. And from the Kubernetes perspective, we are working on this DRA, which is dynamic resource allocation, by which we can have the single GPU serve multiple users. So I'll not go in detail of that, but that is the work what the ecosystem is doing to make sure that that has been enabled, because we want to optimally use the resources what we have. And let me quickly look at what else is here. Cost efficiency, of course, right? Uh, Touched upon the last point itself, right? That whatever we have, we have to optimally use them because they're expensive and supply is limited. So we need to make sure that we can use them effectively. And for that purpose, um, we have, of course, some of the tools are available in the ecosystem there, but more need to be done there for that. Correct. Sustainability is also one of the challenges. Not challenges, not I won't say challenges. Kind of a way which we should kind of go towards, right? Because we know that climate change is happening, and we need to kind of make sure that we don't underutilize our resources, and for that purpose we need to have some kind of mechanism which can kind of tell us that we are kind of over provisioning systems, and we can use our resources in a better way. So like what talked about here is MLCO. I don't know about the particular part, but some of the initiatives are there using which we can take care of or understand how much emissions are happening on the environment from a given model, right? So we need to make sure that we are doing it and we can incorporate them with the help of on the ecosystem of cloud native there. Scalability, of course, is there, right? We should be kind of um, have a way by which we can scale it as per the demands which are talked about, I think, multiple times already. Again, scheduling coming the same part, right? Like we should scheduling it in a better way. And for Kubernetes ecosystem, there is efforts like Unicorn, Volcano, and KQ. So these are the tools are being built on top of Kubernetes, using which we can orchestrate and schedule our workloads on Kubernetes in a much more simpler way, right? And then what mentioned here is training jobs benefit from the scheduling what has been worked out, the Gantt scheduling, which is kind of being worked out there. Um, Let me see this part. Yeah. So the idea here is because of course we know that GPUs coming from NVIDIA, then there may be some other companies who would be building different kind of hardware. So we should have a way by which we can kind of make sure that we kind of communicate together, right? And eventually build some kind of way to optimize multi GPU, multi node communication primitives, right? Because if we have um, if we have different machines available with us, they need to communicate in an effective way. And if we have different versions there, how we can optimally connect them with the libraries or whatever are there, right? By which we can run our workloads in a more effective way. I think that's I think what we can cover in today's session, and we can start with the page 13 next time and try to finish the remaining paper in the next session itself. Um, any points here? Any inputs? Any suggestions?
No, this is good. I wonder if I haven't not read the paper to the end, but I wonder if they're going to talk more about the GPU slicing. Because that's kind of like what this is what it's saying that um the most challenging aspect of this part is that the leverage of the GPU. The GPUs are very expensive, and dedicating a container, like for example, you have one pod dedicated full one GPU to it, it's not going to be fully utilized. So
Hmm.
that's kind of like the challenge. And NVIDIA has an operator, AMD has, the vendors have operators in Kubernetes that you can install that work with the scheduler
Hmm.
to be able to have like two pods, like sharing one GPU, or three pods, depending on how it can be sliced. But at the same time, it could be two pods from two different users or multi-tenancy. So you also want the isolation, but both will be using the same chip, right? And these drivers are not kind of not stable. There's different versions, new versions coming out. They're not, maybe they don't work with the certain versions of Linux or kernels, and then the operator needs to be updated. So there's a lot of challenges around this area, but people are trying to work on that. So that's why I pointed out the working group on the
Yeah.
Kubernetes upstream to see if everything can be consolidated there with same APIs, and then how to work with these devices. Like that's biggest challenge. One of the biggest challenges. The other one is like people have like large container images, like 40 gigs, 50 gigs of images,
Mhm.
and users don't know how to optimize it. Like they have like
Right.
duplicated libraries that they're not using. It's just something they got all the software of a VM right in a container. So that's another challenge.
So
But
this particular also this challenge is what you mentioned. These are the ones that I mentioned in this particular paper,
okay,
but there are no solutions available. I mean, at this point of time, they don't talk about solutions in general in this paper. I believe. I think there are going to be follow-up papers which will talk about individually in a much more deeper sense. This kind of gives you only overview of things that we talked about that, right? That we have. We want to utilize the resources in a better way. So this talked about only what are the different ways of doing things, and
yep,
then there is further pointers which we can refer to, correct?
yep,
But this
yep.
will not kind of go and talk about how to write a YAML file for it, right? Not this paper, maybe later, correct?
Yeah. This is a high level. It's only
Very high
30
level.
pages, so it's very short. So,
Yes.
but it's a good paper for someone that is just um, trying to learn the space, right?
Yes.
Like what are the challenges,
Yep.
basically, right? Go over them, and then how if you're going to do AI on cloud native, which basically for if this is from the CNCF, they're saying Kubernetes, right?
Mm.
How do you do AI on top of Kubernetes? And not a lot of people are doing it, so I think this is a good paper for everyone to read on, like be on the same page of like what are the challenges and why they're there.
Yes, right. And of course, it talks about the shortcomings and which, as a ecosystem, has to work on that, right? So that is also there. Okay. Anybody else has any other comments? Okay. If not, then we are good for today.
I
We'll
just
try.
I
Yeah. Go ahead.
what is the plan for next book?
So next book, I think we'll go with the machine learning on Kubernetes. That is something which we thought, right? And that is all the